it is developed and how it is getting varied. Through the experiment we can obtain the BH curve. It is the very important one. So through that we can found the crystallization slope, so that it may the many applications we may see that. So here we are giving the DC supply, that is the positive and negative. Then the actual current flow we can measure through the ammeter. Here it is the variable rheostat. Okay, through that you can vary the. Initially it was the minimum position. You are trying to vary it. So based on the variation here, it's have the toroidal coil, that is the primary winding and the secondary winding. So the primary winding, it's have the coil, that is the number of turns you may add it N1, and here it is the N2. So here we are varying that. So input voltage also getting varied. So through that here induced EMF has been developed. So there for the measurement purpose, here the secondary side we are counted the some number of turns. Then so the how much force it is has been developed, we are measuring the force through the force meter. Okay, so you can consider the two values, that is the magnetic flux density and magnetic field intensity. So the initially both are it is 0. You see the B as well as H both are it is 0. Okay, while you are trying to increase, it was developed from the region 0 into the maximum level. Okay, while you are moving towards the positive side, so it is trying to increase. So the C is the saturation point. C is the saturation point. So after that, if you are trying to reduce, again it is getting negative side. So it is reached the magnetic flux density line. So that is the residual field. That is the OD. It is the residual magnetic field. Okay. Again, if you are more towards in the negative side, it is again getting down, and it is reached again the origin 0. Here the H is the 0. So that is the corrosive force. Okay, here it is the corrosive force. So if you are again it is reached the negative side saturation, that is the F, and again if you are moving towards the, that is the H. If you are moving in the positive side, again it is reached to the point A, and again it is reached in the point B. Okay, that is the residual side in the positive axis and the negative axis. Okay, that is the BH curve. That is the origin. It is the A, B, and C, D, E, and F. This slope is called, that is the hysteresis slope. Okay, so that is the BH curve. Okay, if you have doubt you may ask. So while you are varying that magnetic flux density, that is the magnetic flux density and field intensity, it is like the corrosive force also getting varied. The corrosive force is nothing but normally that is happen because of the attraction force and repulsion force. We already derived an expression, no? So that force we can call it as corrosive force. The corrosive force is very much large for the ferromagnetic material, and it is a very much lower value. That is the corrosive force. It is the force for the attraction and repulsion force which is developed in the magnetic field. So you all know the magnetic material is classified 3 categories: dia, para, and ferromagnetic material. So the ferromagnetic material, that is it's have the large corrosive force, that means the larger value of magnetic field. You all know that is the relative permeability. It is very much greater than 1. So if you are consider the paramagnetic material compared with the ferromagnetic material, the corrosive force was very small, and the diamagnetic material it was very small. Okay, so that is happen because of the BH curve. Okay, for the analysis purpose, at any case, if you are if you need to analyze the magnetic field intensity and flux density, the hysteresis loop it may plays major role in the many applications. Okay, thank you.